picture the surface of the earth as a thin and quiet skin, soft with soil and forest and stone, stretched over a hidden world that we have only begun to understand. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. Tonight, we will move slowly downward, away from the wind and the light, away from the warmth of the sun, into the long shafts and rooms that thread the rock beneath our feet. The deepest caves we have found drop more than 2,000 meters below the surface. That is more than 2 kilometers of stone, of cold air, of slow water, lying between the explorer and the sky. Veryovkina, in the mountains of the Western Caucasus, has been measured to about 2,212 meters. Krubera, its quiet neighbor, sits close behind. Both lie inside a single mountain range, and both still seem to be hiding more than they have shown us. Imagine standing at the entrance of one of these caves. It might be a small, dark mouth in the side of a green slope, no wider than a doorway, easy to walk past without ever noticing. Cold air drifts out of it. The wind smells of wet stone. Beyond the entrance, the floor begins to slope downward, and the daylight starts to fade behind you. Within a few minutes of careful walking, the outside world has gone quiet. Within an hour, it might as well not exist at all. The descent into a deep cave is unlike anything else on Earth. It is not a hike, and it is not a climb in the usual sense. It is a slow lowering of the body through narrow throats of rock, down ropes anchored to walls, through icy waterfalls and chambers the size of cathedrals. Days pass underground, weeks sometimes. Time stops behaving the way it does up in the air. There is no sunrise to mark the morning, no shadow to mark the afternoon. Only the steady drip of water and the quiet breath of the cave itself. And here is the open question that will sit with us tonight. We do not know how deep the caves of the world really go. We do not know how many of them exist. We do not know how far life can follow the cracks downward into the warm dark of the planet's interior. The deepest known cave today might not be the deepest cave at all. It might only be the deepest one we have managed to reach. Some researchers believe we have mapped only a small fraction of the world's true cave systems. Others suspect that for every kilometer of passage we have measured, there are tens of kilometers more, sealed behind sumps of cold water, or hidden under jungle, or buried beneath ice. The arguments are quiet and patient, the way arguments often are among people who spend long days in the dark. No one really knows the answer. The earth has not finished telling us. The scale of this hidden world is hard to picture. The longest mapped cave system, Mammoth Cave in the state of Kentucky, has more than 670 kilometers of surveyed passage, and surveyors keep finding new branches every year. Sun Dung, in the mountains of central Vietnam, holds a chamber so large that a small skyscraper could stand inside it without touching the ceiling. Lechugia, beneath the desert of New Mexico, hides rooms decorated with crystals that no human eye saw for the entire history of our species until a few decades ago. And these are the caves we know, the ones we have walked into, the ones whose maps are pinned to office walls and folded inside the backpacks of explorers. Beneath them, around them, between them, there are almost certainly other passages, other chambers, other rivers that flow without ever surfacing, whole networks that the slow work of water has carved out of stone over millions of years, waiting in perfect silence. Tonight, as you settle in, we will move gently through this hidden world. We will think about how these caves were born, and about the strange creatures that live without light, and about the cavers who have given years of their lives to descending a little farther into the dark. We will sit with theories, and we will sit with the gaps in those theories. We will hold the central question lightly, the way you might hold a small, smooth stone, turning it over and over, not in any hurry to put it down. To understand a deep cave, it helps to start with something small and slow. A single drop of rain. That drop falls through the sky, brushes past leaves, and lands on a patch of soil. As it sinks into the ground, it picks up a faint trace of carbon dioxide from the breathing of roots and the slow decay of fallen leaves. That tiny gift of carbon turns the water, just slightly, into a weak acid, not strong enough to harm your skin, not strong enough to taste, but strong enough given enough time to eat through stone. This is the quiet secret of most of the world's deepest caves. They are not blasted out by violence. They are not carved by some hidden hand. They are dissolved, atom by atom, by patient water that has learned how to swallow rock. The stone most often dissolved this way is limestone. Limestone is a soft, pale rock made from the crushed shells of creatures that lived in ancient seas. If you held a piece in your hand, it would feel cool and chalky, sometimes flecked with the curled outlines of tiny fossils. Many of the world's great cave systems sit inside thick beds of this old sea bottom, now lifted high into mountains by the slow shifting of the Earth's plates. The caves of the Caucasus, where Veryovkina and Krubera drop more than 2 kilometers down, are carved through such limestone. So are the long, winding passages of Mammoth Cave in Kentucky and the soaring chambers of Sun Dung in Vietnam. The numbers, when you sit with them, are almost difficult to picture. Veryovkina, the deepest cave currently known, reaches down about 2,212 meters. That is more than 2 kilometers straight down into the earth. If you turned the world's tallest building on its side and dropped it into the cave mouth, the building would not touch the bottom. You could stack 6 Eiffel Towers, one on top of the other, and still need a little more height to match it. And yet from the surface, the entrance is small, modest, the size of a doorway in the side of a forested mountain. The age of these places is harder still to hold in the mind. A cave passage may take hundreds of thousands of years to form. Some of the larger chambers in the world's longest systems are millions of years old. The rock they cut through is older still, often laid down on a sea floor 200 or 300 million years ago, long before the first dinosaurs walked. So a cave is a young feature carved through an ancient material, the way a child might trace a finger through dust on a very old table. The shapes that water carves can vary, and this is one of the gentle puzzles of cave science. Some passages are round, almost tube-like, smoothed by water that once filled them completely. Others are tall and narrow, like cracks pulled open, formed by streams cutting downward over long ages. Some chambers open suddenly into rooms the size of cathedrals, with ceilings vanishing into the darkness above. Others squeeze down to slots barely wider than a human body. All of it, in most cases, comes from the same slow recipe: acidic water, soluble stone, time. There is, though, a quieter theory that has grown stronger in recent decades. Some caves, researchers think, may not be carved from the top down by rainwater at all. They may be hollowed from below by warm, acidic fluids rising up from deep in the earth. This idea is called hypogene speleogenesis, and it suggests that some of the strangest caves, with their odd mineral linings and twisted shapes, were shaped by chemistry rising rather than falling. Lechuguilla Cave in New Mexico is often offered as an example. Other researchers point out that surface water still played a role, and that the two processes may have worked together. The question of which caves are which, and how often each story is true, is still being argued. What this means, when you settle into it, is that even the basic recipe for a cave is not entirely settled. We know water dissolves rock. We know rock can be made hollow over enormous spans of time. We know caves can grow downward or upward or both. But the precise balance of forces, the exact age of any single passage, the question of where the water came from and how warm it once was, these things often remain open. Each cave is, in a sense, its own slow experiment, and we are still learning how to read the results, page by quiet page, in the soft, pale dark. High in the western Caucasus, where the green slopes of the Arabica Massif rise above the Black Sea, the ground hides a question that took millions of years to ask. The mountain looks ordinary from above. Soft meadows, scattered pines, white limestone pushing through the grass. But beneath that gentle surface, the rock has been hollowed into one of the deepest known voids on Earth. The cave is called Krubera. For many years, it held the record as the deepest cave ever explored, plunging more than 2,000 meters into the body of the mountain. And the story of how it came to be is still, in many ways, unfinished. To understand Krubera, you have to imagine time slowed almost beyond imagination. The limestone of the Arabica Massif was once a warm, shallow sea. tiny shells and skeletons drifted down, layer by layer, building beds of soft white rock across the floor of an ancient ocean. This was the Cretaceous, more than 100 million years ago. The world above the water held different creatures, different coastlines, a different shape entirely. The stone we now climb down into was, at that time, still being made grain by grain in quiet water. Then, the slow grinding of continents began to lift this seabed. The African plate pressed north against the Eurasian plate, and the rock that had once been ocean floor was pushed up into the sky. Over tens of millions of years, the limestone rose, folded, cracked, and emerged as mountains. Rain began to fall on stone that had never felt rain before, and that is where the real carving started. Rainwater is never just water. As it falls through air and soaks through soil, it picks up carbon dioxide. That makes it slightly acidic, a soft, weak acid, but patient. When this gentle acid meets limestone, it dissolves the rock, atom by atom, along every tiny crack. Drop by drop, century by century, the water widens those cracks into seams, the seams into passages, the passages into shafts. The mountain becomes, in a sense, slowly hollow. In Krubera, this process found a perfect setting. The limestone is thick, more than 2 kilometers thick in places. The mountain rises sharply, which gives the water somewhere steep to fall. And far below, the Black Sea acts like a drain, pulling the underground rivers downward through the stone. Some researchers think the Arabica system may even connect, through unseen passages, to springs that emerge beneath the sea itself. The water has somewhere to go, so it keeps going, and the cave keeps deepening. How long did this take? That is one of the open questions. Estimates suggest Krubera began forming in earnest only a few million years ago, which sounds enormous. But in the world of caves, it is fairly young. Some geologists believe the deepest passages were carved during cold periods, when glaciers above sent torrents of meltwater plunging through the cracks. Others suggest a slower, steadier process, with the cave deepening gradually as the mountains rose. Both ideas may hold pieces of the truth. Both leave gaps. The cave was first entered by Soviet speleologists in the 1960s. At that time, it seemed like a modest find, a few hundred meters deep. No one suspected what lay below. Over the following decades, expedition after expedition pushed further, squeezing through tight slots, rigging ropes down vertical shafts, wading through icy streams. Each trip extended the known depth by a little more, then by a lot more. By the early 2000s, a Ukrainian team reached depths no human had ever stood at within a cave. They named the deepest reached chamber simply, quietly, after the explorers who had come before them. And yet, even now, no one is certain where the true bottom of Krubera lies. The deepest known point sits in a flooded passage, a sump filled with cold, dark water. Divers have pushed into it, but the water continues downward into spaces no light has reached. The mountain has not given up its lowest secret. This is the heart of the mystery for tonight. A cave is not built in a single moment. It is shaped by an enormous patience, by rain meeting stone, by oceans rising into mountains, by water always searching for the lowest place it can find. Krubera is one chapter of a story still being written underground. We know roughly how it formed. We do not know exactly when, or exactly how deep it truly goes, or how many sister passages branch off into the dark, waiting for someone someday to find them. For now, the mountain holds its long, slow answer in silence. In the same quiet corner of the Western Caucasus, where Krubera plunges into the earth, another cave drops even deeper. Its name is Veryovkina. For many years it sat in the shadow of its more famous neighbor, dismissed as a smaller hole, a shorter shaft. Then, slowly, patiently, cavers kept squeezing further down. In the spring of 2018, they reached a sump at a depth of more than 2,200 meters. Veryovkina became, by current measurement, the deepest known cave on Earth. The number itself sounds simple. 2,200 meters of vertical descent. But sitting with that number for a moment changes it. That is more than 2 kilometers of rope, ladder, and cold stone between a caver and the open sky. It is taller, inverted, than nearly every mountain people will ever climb. And the floor of Veryovkina, the place where the water gathers and the passages end in still pools may not actually be the floor. It may only be the deepest place anyone has so far been able to reach. To understand why the bottom remains a question, it helps to think about what the cave is made of. Veryovkina, like Krubera, is carved into limestone. Limestone is a soft, pale rock built from the bodies of ancient sea creatures. Layer upon layer of tiny shells pressed into stone over hundreds of millions of years. The Caucasus Mountains were once seafloor. The very rock that now rises into snowy peaks was, in deep time, a warm, shallow ocean full of corals and plankton. The calcium in those shells came from rivers. The carbon came from the air, and the air, in turn, traces back to volcanoes and to the slow breathing of the planet across ages we can barely picture. So when a caver touches the wall of Veryovkina 2 kilometers down, they are touching something with a very long story. The atoms in that limestone were once dissolved in seawater. Before that, they were locked inside the bodies of creatures so small you would need a lens to see them. And before that, the carbon in those creatures came from carbon dioxide drifting through ancient skies. And the calcium came from rocks that had themselves been weathered out of older mountains in cycles that stretch back to a time when the continents had different shapes. The water that carves the cave is just as well traveled. Some of it fell as snow on the surface only a few decades ago. Some of it may have lingered in the rock for centuries. The hydrogen and oxygen that make up each drop were forged in stars. And in the early universe, then bound together somewhere in the long history of the solar system. One quiet idea among researchers is that much of Earth's water arrived early, locked inside the dust and rock that built the planet. Another idea holds that comets and icy asteroids delivered a meaningful share later on. The debate is not settled. Every drop that trickles down the walls of Veryovkina carries a question we have not finished answering. The air inside the cave has its own chemistry. Near the entrance, it feels much like surface air, though cooler and damper. As you descend, the mix begins to shift. Oxygen drops a little. Carbon dioxide rises. In some chambers, pockets of heavier gas can pool in the low spots, invisible and quiet. The cavers who reached the deep sump in 2018 reported air thick with moisture and slightly harder to breathe. What controls these gas levels, exactly how they vary through the year, and whether deeper passages might hold even stranger atmospheres. These remain open questions, studied a little at a time on each careful expedition. Then there is the matter of the floor itself. The sump at the bottom of Veryovkina is a pool of water that fills the passage to the ceiling. Beyond it, the cave almost certainly continues. Divers have begun to probe these flooded tunnels, but the work is slow and dangerous, and the geometry beyond is unknown. Some researchers suspect the limestone here extends much deeper than the current record, perhaps another kilometer or more before it meets harder, less soluble rock. Others think the deepest passages may pinch shut or twist sideways into networks too narrow to enter. No one yet knows which guess is closer to the truth. So the deepest known floor on Earth is, in a sense, only a pause, a flooded chamber where the rope ends and the water begins. The stone keeps going. The water keeps going. And somewhere below, in the dark patience of the limestone, the real bottom of Veryovkina is waiting, still unmeasured, still unseen. Think for a moment about the caves no one has ever walked through. Not the famous ones with their measured passages and lighted paths, but the hidden ones, sealed inside mountains and beneath plains and under the floors of the sea. They are out there, almost certainly, in numbers we cannot guess. The earth has been folding and dissolving and cracking for billions of years, and water has been finding its quiet way into stone for nearly as long. Cavers and geologists agree on one thing above all. Most of the world's caves remain unfound. The forces that make them work in slow patience. Gravity is the first of these. It pulls every drop of rain downward through soil, through cracks, through the smallest seams in limestone and gypsum. Once that water finds a path, gravity keeps pulling. Year after year, century after century, the water carries a faint trace of acid picked up from the air and the soil, and that acid dissolves the rock one tiny grain at a time. A passage the width of a finger can take 1,000 years to to widen into a passage the width of an arm. The cave grows in the dark, unseen, while the surface above goes on with its weather and its forests. Pressure plays its part too. Deep inside the earth, the weight of all the rock above presses down with a force that is hard to picture. In some places, that pressure squeezes water through pores in the rock at temperatures far higher than anything on the surface. This hot, mineral-rich water rises from below and eats away at the stone from the inside out. Geologists call this hypogene speleogenesis, which simply means cave forming from beneath. It is one of the leading ideas for how the deepest known caves, like Krubera and Veryovkina, may have grown so far down. Hot water rising up, cold water sinking down, and somewhere in between, a meeting point where the rock simply gives way. There is another idea, though, and it sits quietly beside the first. Some researchers think the deepest caves were carved mostly from above, by ordinary rainwater finding ordinary cracks over enormous stretches of time. The mountains of the Western Caucasus, where the deepest known caves lie, have been lifting slowly for millions of years. As they lifted, water kept cutting downward to reach the sea. The cave passages may simply be the long record of that race between rising rock and falling water. Both theories may be partly right. Neither has been settled. Heat shapes caves in other ways as well. In volcanic regions, hot gas and molten rock can carve tunnels of their own, called lava tubes, which sometimes stretch for kilometers beneath old flows. These caves form quickly in geological terms, sometimes in a matter of days. They look nothing like limestone caves. Their walls are smooth, dark, and glassy, frozen in the shape of the last river of fire that passed through. How many of these lie hidden beneath the surfaces of places like Iceland, Hawaii, or the highlands of East Africa is anyone's guess. Then there are the forces we rarely think about. The slow flex of the Earth's crust under the pull of the moon. The faint tides that move through solid rock twice a day, raising and lowering the ground by a few centimeters over millions of years. This gentle squeezing and releasing may open new fractures, or close old ones, or shift the path of underground water in ways no one can easily predict. Some cave scientists wonder whether these tidal stresses help drive the slow breathing of deep cave systems. Others think the effect is too small to matter. The question is still open. What all of this means is that the map of the underworld is far from finished. Satellites can see the tops of forests and the patterns of farmland. They cannot see through hundreds of meters of solid stone. Ground-penetrating radar reaches only a short distance into the earth before its signal fades. The only sure way to find a cave is to crawl into it. And so the forces that built these hidden spaces, the gravity and the pressure and the heat and the tides, have had a long head start on the people trying to understand them. Somewhere tonight, in a mountain that no caver has yet climbed, a drop of water is finishing a journey that began thousands of years ago. It slides down a wall of pale stone, gathers with other drops, and falls into a pool that no eye has ever seen. The cave it lives in has no name. It is one of countless rooms still waiting in the dark, shaped by forces older than memory, holding its quiet until someone, someday, perhaps finds the way in. Picture for a moment what it means to live without ever seeing the sun. Not for a night, not for a winter, but for every generation of your family, going back thousands of years. The deep caves of the world hold creatures who have done exactly this. Their ancestors swam or crawled into the dark long ago, and they never came back out. Over slow stretches of time, the dark became their only home. To understand the scale of this, it helps to think about light itself. In a clear forest at noon, sunlight pours down in a flood. In a typical living room with the lamps on, the light is about 100 times weaker, and our eyes barely notice the difference. Step into a cave entrance, walk a few hundred feet, and the light drops by another factor of 1,000. Walk a little further, and it drops again, and again, until at last you reach a place where no photon of sunlight has ever arrived. Not today, not yesterday, not in any year since the cave was sealed from the surface. That zone has a name. Cavers call it the dark zone, and it begins surprisingly close to the entrance, often within a long city block of daylight. Beyond it lies what scientists call the deep cave environment. In the deepest known caves, This environment stretches downward more than 2 kilometers, about 1.25 miles, and sideways for many more. If you laid the longest mapped cave system in the world, Mammoth Cave in Kentucky, out in a straight line, it would reach from one major city to another. Well, over 600 kilometers of passages, and almost every meter of that distance sits in absolute darkness. Try to feel what absolute darkness means. Close your eyes in a quiet room at night. Some faint glow still reaches your eyelids, a street light, a clock, the moon. In a deep cave with your headlamp off, none of that exists. Hold your hand an inch from your nose, and you cannot see it. Wait an hour, and your eyes do not adjust. Wait a year, and they still do not adjust. There is simply nothing to see. Life in such places has had to invent its own rules. On the surface, almost every food chain begins with sunlight. Plants catch the light, animals eat the plants, other animals eat those animals, and so on. Remove the sun, and the whole chain should collapse. Yet life persists. In some deep caves, scientists have found small ecosystems built entirely on the slow drip of nutrients from above. Bits of leaf litter, drops of water carrying dissolved minerals, the occasional unlucky insect that wanders too far. A single fallen cricket can feed a colony of tiny scavengers for weeks. In other caves, the energy comes from something stranger. Certain microbes feed not on sunlight, but on stone itself, pulling energy from sulfur, iron, or methane in the rock. These tiny lives form the bottom of food chains that have never touched the surface world. One theory holds that such chemical-fed ecosystems may be the truest residents of the deep, the only creatures that could survive if the surface above them froze over for 1,000 years. Another view suggests that even these systems still depend, in small ways, on faint trickles of surface material seeping down. The balance between these two ideas remains genuinely open. The scale of this hidden biosphere is hard to picture. If you weighed all the microbes living in the deep rock and cave systems of the planet, some estimates suggest they would outweigh every land animal on Earth, perhaps several times over. Most of them live in spaces too small for any explorer to enter. Cracks the width of a human hair, pores between grains of stone, films of water clinging to mineral surfaces. The mapped caves we walk through are only the rooms with open doors. Behind the walls, the rock itself is alive in ways we are only beginning to count. How deep does this living layer go? Nobody knows. Microbes have been pulled from boreholes more than 5 kilometers beneath the surface, still alive, still slowly dividing. Some scientists wonder whether life might extend down nearly to the boundary, where the rock becomes too hot to hold liquid water, perhaps 10 kilometers below our feet. Others argue that the truly deep biosphere thins out long before that, surviving only in scattered pockets. The instruments needed to settle the question do not yet exist. So as you drift toward sleep, picture that quiet, lightless world below, full of patient life we cannot fully see. It has been there a very long time. It is in no hurry to be found. Imagine stepping through a low stone arch into a passage no sunlight has ever reached. Your lamp throws a soft yellow circle on the wall, and inside that circle, the world is pale. The rock is the color of old bone, streaked here and there with rust and faint green. Water beads on every surface in tiny silver drops. The air is cool and steady, and somewhere ahead, something moves in the shallow pool at your feet. It is small, and it is white. Not the white of paper, but the soft, translucent white of something that has never needed a color. You can almost see the thin pink line of its blood beneath its skin. It has no eyes. Where eyes might have been, there are only smooth, gentle hollows, as if a sculptor began the face and then chose, kindly, to leave it unfinished. This is an ohm, or perhaps a blind cave fish, or one of the 100 quiet cousins that live in the dark waters of the world's deepest caves. And nobody is entirely sure how many kinds there are. The creatures of the deep passages share a strange family resemblance, even though they are not related. A blind beetle from a cave in Slovenia and a blind shrimp from a cave in Texas may have nothing in common except the dark, yet they look like distant siblings. Pale bodies, long, slow limbs, antennae and feelers stretched out like the long fingers of someone reaching across a dim room. Biologists call this troglomorphy, a soft word for the way that life, given enough time without light, begins to look the same everywhere on Earth. But why this particular shape? And why this particular paleness remains an open question. One theory is simple. In the dark, color costs energy and gives no benefit. Eyes cost energy too, and they can be injured, and they are useless when there is nothing to see. Over countless generations, evolution quietly sets these features aside, the way a traveler sets down a heavy bag they no longer need. Another theory wonders if the loss is more active than that. Perhaps the genes that build eyes are linked to other useful traits in the dark, and turning them off helps the creature in ways we have not yet measured. The truth may be a mix of both. The truth may be something else entirely. Stand a little longer in that lamplit circle, and you begin to see more. A spider with legs as fine as a child's eyelash, walking on the wet ceiling. A centipede the color of fresh cream, threading between two stones. A small white salamander hanging in the still water as if suspended in clear glass. Each of these animals lives an unhurried life. Food in the deep cave is rare. A single piece of leaf, washed in from far away, may feed a whole community for weeks. So everything moves slowly. Hearts beat slowly. Lives stretch long. Some ohms are thought to live more than 100 years, sitting almost motionless in cold underground pools, waiting for prey that may pass only a few times a year. The colors around them are quiet too. Walls of soft cream, floors of pale gray clay, smoothed by the patient feet of water, veins of orange iron like slow brush strokes. Tiny crystals catch the lamplight and flicker like frost. In some chambers, the rock turns a gentle pink, stained by minerals that took thousands of years to settle, drop by drop. In other passages, the stone is almost blue. The deeper you go, the stranger the palette becomes. And yet the eye adjusts, and the dark begins to feel less empty. What no one yet knows is how far down this thin, pale community of life still reaches. Ohms have been found in deep, flooded passages, but the deepest caves on Earth go far below the levels where biologists have searched. In Veryovkina and Krubera, Small invertebrates have been found more than 2 kilometers beneath the surface. Creatures with no name in any book, brought up in jars of cold water and described for the first time by lamplight. Some researchers wonder if life thins out gradually with depth, fading like a long sigh. Others suspect that wherever there is water and a little energy from minerals, something pale and patient will be there too. For now, the deepest passages remain mostly unvisited. The animals living there, if they exist, have never seen a human and never will. They drift through black water that has been black since before our species learned to walk. And in the soft circle of an explorer's lamp, somewhere, one of them may be drifting now. Somewhere on a quiet hillside, a small river flows between mossy banks. The water moves slowly. It catches the green light filtering through the trees. Then, almost without warning, it slips into a dark slot in the rock and is gone. No fanfare, no splash, just a soft hush as the stream disappears into the stone, leaving the bed above bone dry. These are the sinking rivers, and they feed some of the deepest caves on earth. A river that vanishes is a strange thing to stand beside. You can hear it for a moment, gurgling beneath your feet. Then the sound fades, swallowed by layers of limestone. Where does it go? In many places, the honest answer is that no one knows the full path. Cavers can follow the water down for a while. They can swim through low passages and rappel beside waterfalls. Sooner or later, though, the river drops into a crack too narrow for any human body, and the trail ends. The water keeps going without us. It moves through hairline joints and small tubes carved over thousands of years. It may travel for miles before it surfaces again at a spring on the side of a distant valley. To prove the connection, hydrologists sometimes pour harmless dye into the sinking stream. Then they wait. Days later, the dye colors a faraway spring a soft green or red, and the link is confirmed. The water made it. The root, though, remains hidden inside the mountain. Deep caves are shaped by these vanishing rivers. In a system like Krubera or Veryovkina in the Caucasus Mountains, a thin trickle on the surface can become a roaring underground stream a kilometer below. The water cuts shafts straight down through the limestone, polishing the walls smooth. It pools in cold lakes. It spills over ledges in long, thin waterfalls that cavers must descend beside, soaked and shivering, rope by rope. What makes these rivers so puzzling is how little we can see of them. A surface river is mapped from helicopters and satellites. Its bends and tributaries are known. An underground river hides behind solid rock. Cavers piece together its shape one room at a time, sketching by headlamp, measuring with tape and laser. The map grows slowly. Between the drawn passages, there are always blank spaces, places where the water clearly flows, but no human has ever followed. Some of these hidden rivers may be very old. One idea is that certain underground streams have been carving the same routes for hundreds of thousands of years, slowly enlarging tubes that began as tiny cracks. Another idea is that many cave rivers are younger, shifting their paths as the land above lifts and tilts. Both ideas can be true in different places. The truth depends on the rock, the climate, and the long history of the region. In most caves, that history is only partly understood. Then there are the sumps. A sump is a place where the passage dips below the water table and floods completely. The river continues, but the air above it ends. To go further, a caver must dive. Cave diving in these deep, narrow, flooded tunnels is one of the most demanding things a person can do underground. Visibility can drop to nothing in seconds when silt is stirred. The walls are close. The way out is the same way in. Many of the deepest caves end, for now, at sumps that no one has yet pushed through. What lies beyond those flooded passages is one of the quietest mysteries in earth science. The river clearly continues. The cave clearly continues. Whether the rooms beyond are small and tight, or huge galleries no one has seen, is simply unknown. Sometimes a diver pushes a sump and finds dry passage on the other side, opening kilometers of new cave. Sometimes the sump goes on, and the explorer must turn back. The mountain keeps its secret for another year. Standing in a chamber where a river falls into a black slot, you can feel the pull of that unknown. The sound of the water echoes off walls you cannot quite see. A cool breeze rises from the crack, carrying the smell of wet stone. The river is heading somewhere. It has been heading there, drop by drop, since long before anyone walked above. Tonight it is still going in the dark, under sleeping hills. How much of Earth's underground water moves through caves we have never entered? Hydrologists offer rough guesses, but the number is genuinely uncertain. The rivers that vanish into stone may join networks far larger than the ones we have mapped. For now, the listening is the closest thing to an answer. The water hushes into the rock, and the question hushes with it. Caves breathe. It sounds strange to say, but it is true. If you stand at the mouth of a deep cave on a quiet day, you can sometimes feel a soft draft on your face. The air is moving in, or it is moving out. The mountain is exhaling, or it is drawing in a long, slow breath. This breathing is one of the gentler mysteries of the deep underground. Cavers have known about it for centuries. Old miners spoke of caves that sighed before storms. Some entrances whistle softly when the weather shifts. Others fall silent for hours, then begin to move air again without warning. The pattern is real, but the full picture of why it happens is still being worked out. One theory is simple. The cave breathes because the air inside it stays at a steady temperature, while the air outside changes with the day and the season. Deep caves hover near the average yearly temperature of the land above them. That can be cool, like the inside of a cellar, or warmer in tropical places when the outside air gets colder than the cave. The heavier cold air sinks in through low entrances, and the lighter warm cave air drifts out through higher ones. When the outside air warms above the cave, the flow reverses. The mountain breathes in summer one way and in winter the other. Another theory points to air pressure. As storms approach, the pressure outside drops. The cave, sealed within tons of stone, cannot adjust quickly. The trapped air pushes out through the entrance until the balance is restored. When a high-pressure system arrives, the cave inhales. Some caves seem to predict the weather hours before clouds appear above. The connection is well documented. The exact path the air takes through unseen tunnels is often still a guess. Both theories are likely true at the the same time. In long systems with many openings, temperature drives most of the flow. In sealed pockets with only one small mouth, pressure does the work. In a cave like Veryovkina or Krubera, where the passages drop more than 2 kilometers and twist through countless side chambers, the breathing must be far more complex. Cavers have reported drafts that come and go without a clear pattern. They feel the air move and cannot say where it began or where it is going. These breaths matter to the life below. The moving air carries moisture, oxygen, and traces of the world above. It thins out heavy gases that can pool in low chambers. Carbon dioxide, in particular, can settle into invisible lakes at the bottom of certain passages. A cave that breathes well stays safer for the creatures inside it, and for the rare visitor with a headlamp. A cave that stops breathing, even for a season, can grow stagnant. The air becomes thick, and the cavers turn back. There are longer rhythms too. Some caves seem to breathe with the seasons in patterns that span years. After a wet winter, the airflow strengthens. After a long, dry stretch, it slows. Water seeping through the rock changes how much room the air has to move. The whole system rises and falls like the slow swell of a calm sea. No one has fully mapped these long rhythms. The instruments that would track them must sit in the dark for decades, and very few have done so. Even longer cycles may be hidden in the stone. Over thousands of years, glaciers come and go above some of the deepest caves. The weight of the ice presses down on the rock. The melt sends new water into the system. The air patterns must shift in ways we can only imagine. A cave that breathes one way today may have breathed quite differently when mammoths walked the surface. Some researchers wonder if the cave atmosphere itself preserves clues to these older rhythms, locked into thin films of mineral on the walls. For now, much of this remains an open question. We can measure the air at a few entrances. We can place sensors a few kilometers in. The deepest reaches, beyond the sumps and the narrow squeezes, stay unmeasured. We do not know how the air moves in chambers that no one has yet entered. We do not know if there are pockets that have not exchanged with the surface for centuries. It is a strange thought to carry into sleep. Beneath the quiet hills and the sleeping forests, the stone is breathing. Slowly, steadily, in rhythms older than any human voice. The caves draw in the cool night air and let it out again at dawn, keeping a pulse the world rarely notices. In a darkness no one has fully seen. Deep inside a cave, the path does not always continue through open air. Sometimes the floor simply ends in still, dark water. The tunnel keeps going, but it goes underwater, and a caver who wants to follow must either turn back or dive. These flooded passages have a name. They are called Sumps, and they are some of the most mysterious neighbors a deep cave can have. A sump is a place where the cave passage dips below the water table. Water fills it completely, from floor to ceiling, with no air space at all. Some sumps are short. A diver can swim through in a minute and come up on the other side in a new dry chamber no one has ever seen. Other sumps go on for hundreds of meters. A few stretch for kilometers, and some no one has ever reached the end of. A siphon is a close cousin. In cave language, a siphon is a passage where water has pooled and blocked the way forward, often at the lowest point of a tunnel. The shapes are similar. The mystery is the same. Beyond the still surface of the water, the cave keeps going, but the human cannot easily follow. Cave divers are a small and careful group. They carry tanks of air on their sides instead of their backs, so they can squeeze through narrow gaps. They unspool thin lines behind them, so they can find their way back through the silt. Visibility can drop to nothing in seconds. One kick of a fin can stir up the floor and turn clear water into a brown cloud. In that cloud, the only way home is the line. Because of this, the flooded parts of deep caves are mapped slowly. A single dive might add only a few hundred meters to the known length of a system, and yet these flooded passages may hold the answer to one of the oldest questions in cave science. How are the great cave systems connected? On the surface, two caves might have separate entrances, kilometers apart, on different sides of a mountain. Underground, their lower passages may meet in a sump no one has yet swum through. If a diver could pass that sump, the two caves would become one, and the new combined system might suddenly be the longest or the deepest in the world. Some of the famous record holders grew this way, joined by a single brave passage that someone finally got through. In Florida, in Mexico, in the limestone hills of France and Italy, divers have linked caves that locals thought were separate for generations. The Yucatan Peninsula sits over a vast network of flooded passages, and new connections are still being mapped. In some places, the sea has risen and fallen so many times that what is now underwater was once dry, walked by animals whose bones now rest on the cave floor under the slow, clear water. There are also sumps that no one has tried. Some are too narrow. Some are too deep. Some lie at the end of a journey so long that no diver has yet had the time or supplies to reach them and still come back. These are the quiet doorways of the deep cave world. They sit full of dark water, waiting. How much of the global cave network lies beyond such doors? The honest answer is that we do not know. One view, held by many cave scientists, is that the dry, walkable caves we have mapped are only a small part of the true system. The rest is flooded and always was. Another view suggests that many of those flooded passages are dead ends, plugged with sediment, no longer connecting to anything larger. Both can be true in different places. Both leave the central question open. The water itself adds to the mystery. It is often startlingly clear, with a pale blue or green tint where any light reaches it. The walls of a flooded passage can be smoother than the dry ones, sculpted by slow currents over thousands of years. Tiny pale creatures sometimes drift through, almost invisible, their long bodies translucent. What lives in the deepest, longest sumps, in water that has never seen a torch beam, is still being discovered. For now, picture the still surface of a sump at the end of a long, dark passage. The cave divers have not yet arrived. The water has not been stirred in years. Above it, the rock arches into darkness. Below it, the tunnel continues into a part of the earth that no human has ever entered. It is not a frightening thought. It is a quiet one. The cave is simply waiting, the way it has waited for a very long time, while the world above turns slowly on. The deepest caves on Earth ask more of a human body than almost any other place on the planet. To reach the bottom of Veryovkina in the limestone mountains of Abkhazia, a caver must travel down for days. Not hours, days. They rappel through narrow shafts, wade through icy underground rivers, and sleep in tents pitched on small ledges far below the surface. The trip down can take a week. The trip back up takes longer. At those depths, the world becomes a series of extremes layered one on top of another. The temperature settles near freezing and stays there. The humidity reaches almost 100%, so every breath fogs the air, and every piece of gear stays damp. There is no day. There is no night. There is only the small circle of a headlamp and the long black space beyond it. Cavers describe a kind of tiredness that has no name on the surface, a slow weight that builds in the bones after days without sun. The records held by these deep caves are quiet records. Veryovkina, at more than 2,200 meters below its entrance, is the deepest known cave on Earth. Krubera, just a few kilometers away in the same mountain range, held that title for years and may yet reclaim it if new passages are found. The two caves sit in the same massif, and some researchers suspect they may even share water at depths no one has reached. Other caves hold other extremes. Sun Dung in Vietnam contains the largest known cave passage in the world, a tunnel so vast that a jungle grows inside it under skylights of collapsed ceiling. Mammoth Cave in Kentucky is the longest known cave system, with more than 670 kilometers of mapped passages, and likely far more still hidden in the soft limestone. Lechuguilla in New Mexico holds some of the most delicate mineral formations ever found. Gypsum chandeliers and rare crystals that grew in still air for millions of years. The cavers who explore these places understand the risks. Flooding is the most feared. A storm on the surface can send water roaring through passages that were dry an hour before. Rockfall is another quiet danger, especially in young caves where the walls have not yet settled. And then there is simple distance. Help cannot reach the bottom of Veryovkina quickly. A serious injury at that depth becomes a rescue that may take days. sometimes weeks, involving dozens of cavers working in shifts to lift one person back toward the sky. There have been losses. The history of deep caving holds names of explorers who did not return, swept away by sudden floods, or trapped by collapses, or lost in flooded passages beyond the reach of their air. These stories are spoken of softly in the caving community, with respect rather than drama. Each loss has taught the others something about timing, about weather, about the slow, careful patience the deep caves demand. The mystery at the heart of these extremes is how much further any of this can go. No one knows for certain how deep a human can travel under the earth. The current record stands near 2,200 meters, but the caves themselves may continue far below the lowest known floors. Some researchers suspect that flooded passages beyond the deepest sumps lead to chambers still deeper, perhaps another 500 meters down, perhaps more. Others think the soft limestone gives way at some depth to harder rock that simply does not form large caves. The evidence is incomplete on both sides. There is also the question of the human body itself. At extreme depths, cavers face long periods without sunlight, constant cold, constant damp, and the slow buildup of carbon dioxide in poorly ventilated chambers. Some expeditions have reported strange shifts in sleep patterns, in mood, in the sense of time. One idea is that the brain, deprived of all surface cues, simply drifts. Another idea is that the slightly elevated carbon dioxide of deep cave air affects thinking in ways we do not yet fully understand. Both may be partly true. Neither has been studied as carefully as it could be. For now, the deepest caves remain a place where the records are still being written slowly by small teams in small headlamps moving through enormous dark spaces. Each new expedition pushes a little further, maps a little more, and returns with new questions about what lies beyond the last known chamber. The bottom of the Earth's caves, wherever that bottom truly is, has not yet been found. It waits, patient in the dark, somewhere below the deepest place a human boot has ever touched. There is something quietly remarkable about the maps that cavers draw. They are not made from satellites or drones. They are not pieced together from photographs taken high above. They are sketched line by careful line in the dark. A surveyor stands in a narrow passage, holding a small compass and a thin measuring tape. Another caver waits in the gloom ahead, a soft light fixed to their helmet. Between them, the cave reveals itself one short measurement at a time. This is the slow art of cave survey. A team will measure the distance from one station to the next. They will note the angle of the slope, the bearing of the passage, the height of the ceiling, the width of the walls. They will sketch the shape of the rock around them in a small, waterproof notebook. Then they will move forward a few steps and do it all again. A kilometer of cave passage can take many days to map this way. Some of the deepest systems have taken decades. The notebooks themselves are small treasures. The pages are often gray with mud, the corners curled from damp air. The pencil lines wobble where a cold hand was trying to hold still. In the margins, surveyors sometimes write little notes. A drip from the ceiling, a patch of strange crystal, a small white spider paused on a wet wall. These notes, gathered over years, become the soft texture of a cave's biography. When the team returns to the surface, the numbers are entered into computers. The software draws the cave as a thin, three-dimensional thread, twisting through invisible stone. Seen from above, a great cave looks almost like the root system of an enormous tree. Branches split, rejoin, drop suddenly into deeper levels, and reach outward in directions no one expected. The shape is beautiful in a quiet way. It is also almost always incomplete. Most maps end at a question mark where the passage went on, but the surveyors had to turn back. The smallest details often matter most. A surveyor might notice that the walls in one chamber are not smooth, but pitted with tiny round hollows, each the size of a fingertip. These are called scallops, and their size hints at how fast water once flowed here. Smaller scallops mean faster water. Larger scallops mean a slower, gentler current. By reading the walls, cavers can sometimes guess the speed of a river that vanished long before any human was born. Other walls show fine parallel lines, etched like the grain in in old wood. These can record the level of ancient floods, each line marking a moment when the water stood still for a season or a century. In some chambers, a careful eye can find small shelves of pale stone jutting from the wall. These are old water lines, frozen in mineral. They show where a slow lake once rested in the dark, drop by drop, leaving a faint rim behind. Under a microscope, the strangeness deepens. A pinch of cave mud may contain tiny grains of quartz, polished smooth by water, fragments of bat bone thousands of years old, and pollen from forests that no longer exist on the surface above. Cavers sometimes collect small samples in clean vials and pass them to researchers in distant labs. From a thimble of sediment, scientists can sometimes reconstruct a portrait of a vanished climate. Even the air can be measured. Cavers carry small devices that read temperature and humidity, and sometimes the level of carbon dioxide. In certain deep chambers, the readings barely change from one year to the next. The cave keeps its own quiet weather, almost untouched by the seasons rolling above. The numbers, written carefully in a notebook, look unremarkable. The meaning behind them is harder to grasp. These pockets of stillness may have held the same temperature for thousands of years. How much of all this remains unmapped is itself an open question. Some researchers estimate that the world's known caves are only a small fraction of what lies beneath us. Others suggest the unknown share is larger still, hidden under mountains, jungles, and ice that no survey team has yet reached. Both views agree on one thing. There is more cave than there are cavers, and more passage than there is time. So the maps grow, line by patient line. A small light moves through a great darkness. A pencil scratches softly against damp paper. Somewhere in the world tonight, a surveyor is kneeling on cold stone, taking a reading they will not finish entering for another week. The map of the underworld is being drawn slowly by hand, and the blank spaces around it are still vast. The earliest cave explorers left no journals. They left only soot on the walls and the occasional footprint pressed into soft clay. In places like Bruniqual, deep inside a cave in southern France, researchers found rings of broken stalagmites arranged by hand. The stones were snapped, stacked, and burned at their edges. The age came back as something close to 170,000 years. That is older than our own species in many estimates. Who lit those fires, and why they went so far into the dark remains an open question. For most of human history, caves were thought of as mouths in the earth. People entered them a little way, took what they needed, and left. The deeper passages stayed unknown. There was no light bright enough, no rope long enough, no map clear enough to follow. The sound of a cave at rest is a soft, slow dripping. And for a long time, that sound was all anyone heard before turning back. The idea of caves as a science came slowly. In the 17th and 18th centuries, a few curious naturalists began climbing down into the openings near their homes, sketching what they saw by candlelight. They wondered where the rivers went. They wondered why the air felt different. They argued about whether caves were carved by ancient floods, or by slow water, or by some hidden fire below. None of them could agree, and most of them never went very deep. The man often credited with founding the modern study of caves was a Frenchman named Edouard Alfred Martel, working in the late 1800s. He carried rope ladders, collapsible boats, and oil lamps into pits no one had measured. He gave the field a name, speleology, from the Greek word for cave. He believed that caves connected to the surface in ways that mattered for drinking water, and he was right. His maps were rough, but they were the first serious attempt to treat the underworld as something that could be studied, measured, and understood. Even then, the deepest parts stayed hidden. Early cavers had no idea how far down the systems went. They guessed in hundreds of feet, then in thousands. The instruments were simple: a weighted line, a barometer to estimate pressure, a compass that sometimes spun for reasons no one could explain. Mistakes were common. Depths were overstated, then corrected, then overstated again. A cave that was once called the deepest in the world would be quietly demoted a few years later when someone measured more carefully. The breakthrough came with better gear. Electric headlamps replaced candles. Nylon rope replaced hemp. Single rope technique developed in the middle of the 20th century allowed a single caver to descend hundreds of meters on a thin line, then climb back up the same line using small mechanical clamps. Suddenly, the pits that had stopped earlier explorers became passable. The deep caves of the Pyrenees, the Alps, and the Caucasus began to give up their numbers. The race to find the deepest cave on Earth started quietly in the 1970s and 80s. Teams from France, Spain, Italy, and the Soviet Union pushed into systems that seemed to keep going. Each expedition added a few hundred meters. Each one came back with stories of narrow squeezes, cold rivers, and chambers so large their lamps could not reach the far walls. The record passed from cave to cave. The Pier Saint Martin in the Pyrenees held it for a while. Then a cave in Austria. Then the systems of Abkhazia in the Western Caucasus took the lead and have held it for the last 2 decades. What is striking about this history is how recent it is. The deepest known caves were not measured until our own lifetimes. The bottom of Krubera was not reached until 2004. Veryovkina was not pushed past 2 kilometers until 2018. The instruments are now precise. Laser rangefinders, digital depth gauges, satellite-linked maps drawn on tablets in the dark. And yet the mystery has not closed. Every new descent raises the question of whether the bottom has actually been found, or only the deepest point a human body could safely reach. The sound of a cave at rest has not changed. The drip is the same drip the first fire makers heard in Bruniquel. The cold is the same cold. What has changed is our patience, our gear, and our willingness to keep going down when the passage narrows. Whether anyone will ever stand at the true floor of the deepest cave, or whether such a floor exists at all, is a question the instruments have not yet answered. For now, the lamps keep moving slowly into the dark. Deep inside certain caves, where no person has ever spoken and no wind has ever stirred, crystals grow. They grow slowly in absolute darkness, in water so still it could be mistaken for glass. Some of them are no larger than a grain of salt. Others are the size of a tall tree. The largest crystals ever found on Earth do do not sit on a mountaintop or in a museum case. They lie hidden inside a cave in northern Mexico, in a chamber that once held water hotter than a warm bath, for perhaps 500,000 years. That place is called the Cave of the Crystals, deep beneath a working mine. The crystals there are made of selenite, a soft, pale form of gypsum. Some of them stretch more than 30 feet across, like fallen columns from a forgotten temple. They lean against one another in great pale beams, smooth and glossy, almost translucent. When light touches them, they seem to glow from within. For most of their long lives, they grew in total darkness, bathed in mineral-rich water that barely moved. Slowly, atom by atom, they became the largest natural crystals known anywhere on the planet. What makes them strange is not only their size. It is the patience that built them. To grow a crystal that long, the water around it must hold a nearly perfect temperature for thousands upon thousands of years. Even a small shift and the growth stops. Even a small tremor and the lattice cracks. The cave kept its quiet for so long that the crystals were able to keep adding to themselves, one slow layer at a time, in a silence almost impossible to imagine. Other caves hold their own quiet surprises. In Lechuguilla, deep beneath the New Mexico desert, the walls bloom with shapes that should not exist by ordinary logic. There are gypsum chandeliers that hang from the ceiling like frozen waterfalls, some 20 feet long. There are delicate aragonite frostworks that look like white coral. There are pale formations called halictites that twist sideways and upward, defying the simple pull of gravity. No one is entirely sure how halictites form. One idea is that water seeps through them so slowly that surface tension, not gravity, decides their direction. Another idea points to tiny impurities in the rock that guide each new layer in unexpected ways. The question remains open. Lechuguilla also taught geologists something they had not expected. For a long time, most researchers believed caves were carved from the top down, by rainwater seeping into limestone from above. Lechuguilla seems to have formed the other way. Acidic water rising from deep below ate the rock from beneath. This process is called hypogene speleogenesis, a long phrase meaning made from below. Some scientists now wonder how many other deep caves were shaped this way, hidden beneath mountains where no surface stream ever flowed. Others argue that the evidence is still patchy, and that each cave must be read on its own terms. There are stranger surprises still. In some caves, the walls are coated in pale, sticky films of microbes. These living mats slowly eat the rock itself, releasing acid that hollows out new passages. The caves, in a sense, may be partly carved by life. Some researchers believe these microbe communities have been working on the stone for millions of years, quietly enlarging chambers we once thought were shaped only by water. How much of the underworld owes its size to living things is still being studied. In the cool dark of certain caverns, water drips into shallow pools and forms cave pearls, smooth, round stones that look almost polished by hand. A grain of sand begins it. Mineral-rich water washes over it, drop by drop, century after century. The grain rolls and turns in its little basin, gathering layer after layer until it becomes a tiny sphere of stone. Cut one open, and you find rings like the rings of a tree, recording all the seasons it never saw. And then there are the cave clouds, the cave flowers, the boxwork lattices that look like honeycomb made of stone. Each one is a record of water and mineral and time, written in a language we are still learning to read. Many of these formations grow at rates almost too slow to measure, perhaps a hair's width in a human lifetime. We see them only in their finished state, and we can only guess at the slow patience that built them. The deeper question lingers. If life and water and stone can build such quiet wonders in the dark, what else waits, untouched, in chambers no one has ever entered? The crystals keep growing. The silence keeps deepening. And the answer keeps drifting just out of reach. Deep inside the largest caves, the air does not sit still. It moves. It drifts in slow currents through tunnels and chambers, sometimes warm, sometimes cool, sometimes carrying the faint smell of wet stone and old water. Cavers have long known that a cave can seem to breathe. Stand at the mouth of certain caverns on a summer afternoon, and you can feel a cool wind flowing out from below. Return in winter, and the same opening may pull air inward, like a great slow lung. The cave is not alive, of course, but it is connected to the world above in ways we are still learning to read. The simplest explanation has to do with temperature. A deep cave holds a steady inner temperature, close to the average yearly temperature of the surface above it. When the outside air is warmer than the cave, the heavier, cool air inside slides out along the floor. When the outside air is colder, the warmer cave air rises and escapes through upper openings, drawing fresh cold air in from below. This is the chimney effect, and it can move surprising volumes of air through a mountain. Some long cave systems have two entrances at very different heights, and the wind between them never quite stops. Yet, temperature alone does not explain everything. Some caves seem to breathe even when the outside air matches the inside. One idea is that changes in air pressure on the surface from passing storms and weather fronts push and pull on the trapped air below. As the pressure outside drops, the cave exhales. As the pressure rises, the cave inhales. A single deep system can take many hours, even days, to finish a single breath. Other researchers suggest that water moving through hidden passages also pushes air ahead of it, like a slow piston in the dark. Both forces may work together. The exact mix likely differs from cave to cave, and much of it remains an open question. These quiet winds shape the world inside the cave. They carry moisture, which feeds the growth of crystals and slow stone curtains on the ceilings. They carry spores and tiny grains of dust, sometimes from far away on the surface. They carry warmth in and cold out, smoothing the temperature into the steady hush that cave life depends on. Without this gentle breathing, many caves would grow stale, their pockets of bad air untouched for centuries. In some chambers, though, the air does grow heavy and still. Carbon dioxide, which is denser than ordinary air, can pool in low rooms and dead-end passages, forming invisible lakes you cannot see or smell. Cavers have learned to test the air carefully before crossing certain thresholds. Where this carbon dioxide comes from is itself a quiet puzzle. Some of it seeps up from deep rock, released by slow chemical reactions far below. Some drifts down from soil and plant roots above, carried by water and gravity. The balance between these sources shifts from cave to cave and from season to season. The strangest weather of all may happen in the great chambers, where caves grow large enough to hold their own small climates. In Sun Dung in Vietnam, the main passage is so vast that clouds have been seen forming inside it. Warm, humid air rising from a hidden river meets cooler air drifting down from above, and a soft mist gathers near the ceiling, hundreds of feet overhead. In some caves, the difference between the floor and the ceiling can be enough for thin layers of fog to come and go through the day. The cave keeps its own slow weather, untouched by sun or wind. All of this connects the buried world to the living surface in ways that are easy to miss. A thunderstorm rolling over a mountain ridge can change the wind in a tunnel a mile below. A long drought can quiet the dripping in a chamber that has not been silent in centuries. A heavy snowfall can slow the breath of a cave for weeks, sealing its upper entrance under white. The cave listens to the sky in its own muffled way. How far this conversation reaches, we do not fully know. Some researchers wonder whether the deepest unexplored systems may have airflows we have not yet measured, currents that move along passages no human has entered. Others suspect that some chambers are nearly sealed off, breathing only across the scale of years. Both ideas may be true in different places. The mountains above hold their weather in clouds and rain. The caverns below hold a weather of their own, slower and darker, drawn from the same restless atmosphere. Written in winds we are only beginning to feel. Deep inside many caves, beneath the slow drip of water and the long quiet of stone, there is a layer of soft sediment on the floor. It looks like nothing much at first. A pale dust, a damp clay, a heap of pebbles where an old stream once ran. But buried in that sediment, sometimes only a few inches down, lie bones. The bones of animals that wandered in long ago. The bones of creatures that no longer walk the earth. And in some caves, the bones of people who came inside thousands of years before anyone wrote down their names. Caves are unusually patient places. On the surface, wind and rain wash away the traces of the past quickly. A bone left in a forest may be gone in a season. But inside a cave, the air stays still. The temperature holds steady. Water moves slowly, when it moves at all. A bone that falls into cave sediment may rest there for tens of thousands of years, slowly soaking up minerals from the stone around it. Over time, the bone itself becomes part of the cave, hardening into something almost like rock. This is how caves have become quiet archives of deep time. In some chambers, researchers have found the remains of cave bears, huge animals that vanished from Europe more than 20,000 years ago. In others, they have found the teeth of small horses, the claws of extinct sloths, the skulls of strange hyenas that once roamed warmer continents. Each layer of sediment is a little chapter, and the deeper you dig, the further back you go. A single cave floor can hold 100,000 years of slow accumulation, stacked one fine layer at a time. What changes from layer to layer can be quite surprising. A cave that today holds only bats and pale insects may, in its deeper sediments, contain the bones of animals that needed wide, open grasslands. The climate above the cave shifted. The forests retreated. The grasslands came and went, and the cave, sealed away from the weather, kept a record of which creatures stumbled in during each long chapter. Some researchers see caves as among the best places on Earth to study how life on the surface has changed across the long arc of the ice ages. The mystery deepens when human remains appear. In certain caves in southern Africa, in Southeast Asia, in the limestone hills of Europe, scientists have found bones of early humans and their close relatives. Some of these bones sit in places that are hard to reach even today. They lie behind tight crawls, down vertical drops, far from any easy entrance. How did the bones get there? One theory is that the cave openings were once much wider, and what is now a difficult passage was once a simple walk. Another theory holds that early humans deliberately carried their dead into the dark. A third possibility is that the bodies were washed in by ancient floods or dragged in by predators long gone. In most cases, the evidence is incomplete, and the debate continues quietly in scientific journals, what is happening right now in these sediment layers is just as interesting. The bones are not finished changing. Water still seeps through the cave, leaving thin films of calcite over every surface. Slowly, very slowly, the older bones are being absorbed into the floor itself. Some are dissolving. Some are being preserved more deeply, locked into the stone like fossils in the making. In another 100,000 years, the bones we find today may be unrecognizable, or they may be perfectly preserved in glittering crystal. Caves are not still places. They are simply places where change moves at a different speed. There is also a quieter sort of change. Each year, a few more grains of clay drift down from the ceiling. A few more pebbles wash in during a storm above. A bat dies and falls. A beetle finishes its life in a damp corner. These tiny additions, almost too small to measure, are still being added to the floor right now, in caves all over the world, while you lie listening. The archive is still being written, and much of it has never been read. Most cave sediments have never been carefully dug, because most caves have never been carefully explored. How many lost creatures rest in those untouched layers, waiting in the dark? We do not know. Some researchers believe the deepest sediment records of Earth's recent past may still be sitting quietly beneath us. In caves no one has yet found. Whether we will ever read those pages is one more open question to carry into sleep. The longest cave tunnels on Earth tend to hide beneath mountains. Not just any mountains, but ones made of pale, soluble stone, limestone laid down in ancient seas, then lifted high by the slow shove of colliding continents. From the outside, these mountains look ordinary. Forests cling to their slopes. Mist gathers in their valleys at dawn. A walker on the ridge might never guess that just below, in the dark, a hollow world stretches for hundreds of kilometers. Light is the part of the story these mountains keep for themselves. The sun falls on the green canopy and the gray cliffs, and it stops there. It does not pass through stone. Whatever lies inside lives in a darkness so complete that a human eye, given 1,000 years to adjust, would still see nothing. And yet, the way light behaves at the threshold, at the mouth of a cave in those first 100 meters tells us something about everything that lies beyond. Stand at the entrance of a great cave in a limestone mountain, and you can watch the light die. It does not vanish all at once. It fades in stages, almost reluctantly. The bright daylight at the opening softens to a warm gold on the first walls. A little deeper, the gold turns to a cool gray. Deeper still, a blue twilight settles, the kind of color the sky takes on just after sunset. Plants thin out here. Mosses cling to the last patches of brightness. A few pale ferns lean toward the entrance, their leaves stretched wide to drink whatever scraps remain. Then comes the twilight zone, where photographers love to point their lenses. Shafts of light spear down from skylights in the ceiling, where the roof has collapsed long ago. In a cave like Sun Dung in Vietnam, those shafts are wide enough to grow a forest inside the cave itself. Trees rise from the cave floor, reaching up through the beam of daylight, their leaves green and ordinary, as if they had no idea they were growing inside a mountain. Mist curls through the columns of light. Birds nest on the walls. For a few 100 meters, the cave pretends to be the outside world. The pretense ends quickly. Past the last skylight, the dark zone begins. Here, no photon ever falls naturally. The walls hold colors they earned millions of years ago. Rusts, ambers, soft creams, the deep gray of wet stone. But those colors mean nothing without a lamp to wake them. A caver's headlamp, passing through one of these chambers, reveals a palette that has waited untouched since the chamber formed. The light moves on. The colors sleep again. How much of this hidden world have we actually seen? The honest answer is that we do not know. Mammoth Cave in Kentucky has been mapped to more than 670 kilometers of passage, and surveyors keep finding more every year. Some researchers think the true extent could be twice that, perhaps far more. Other karst regions in southern China, in Slovenia, in the highlands of Papua New Guinea, hold mountains so riddled with passages that no team has ever finished mapping a single one. Each new expedition adds tunnels. None close the book. One idea is that the longest cave systems in the world are still waiting to be connected. Cavers find two separate caves, each many kilometers long, and suspect they meet somewhere in the dark. Sometimes a diver squeezes through a flooded passage and proves the link. Sometimes the link is never found, and the two caves stay listed as separate, even when the airflow between them hints at a shared interior. A competing view holds that many of these suspected links may never exist, that the stone between them is too tight, the passages too choked with rubble, and the real network is more broken than it looks. Both views remain alive. Both await better evidence. What we can say is that light has only ever touched the smallest fraction of these worlds. The headlamps and helmet lamps of cavers, the strobes of cameras, the slow sweep of survey lasers. Together, all the light ever shone inside the deepest mountains adds up to a thin, flickering thread. The rest is darkness. The rest is the original condition of these places, the way they have been for tens of millions of years, the way they will be again the moment we leave. A mountain that hides 100 kilometers of tunnel does so quietly, without effort. It simply stands there in the rain, gathering water on its summit, letting that water slip down through cracks no human has ever seen. The light stops at the door. The mystery begins on the other side. Deep inside certain mountains, the cold never lifts. There are caves where the rock holds onto winter all year long, and inside them, ice grows in slow, strange shapes. These are the ice caves, and they make sounds unlike any other place underground. The ice itself speaks. It groans, it ticks, it sighs as it settles against the stone. If you stood quietly in one of these chambers, you would hear a soft chorus of small noises. Water drips somewhere far off, each drop landing on ice rather than rock. The sound is muted, almost felt more than heard. Now and then, a sharp crack travels through the cavern as the ice shifts by the width of a hair. The mountain above presses down. The cold pushes back, and the ice keeps its slow conversation with both. Some of these caves sit high in the Alps, others in the Carpathians, others in the long limestone ridges of Eastern Europe and Central Asia. The air inside them stays below freezing even when summer warms the slopes outside. Cold air is heavy, and it pools at the bottom of certain caves, like water in a basin. Warm air cannot easily push it out. So winter, in a sense, gets trapped, and the ice that forms inside is shielded from the seasons. How long has this ice been there? That is the question researchers keep asking, and they do not fully agree on the answer. One idea is that some of these underground ice deposits are very young, only a few hundred years old. In this view, ice forms and melts on a slow cycle, building up during cold centuries and thinning during warmer ones. The ice you see today might be only as old as a few human generations. The sounds inside the cave, then, are the sounds of a living, breathing system that resets itself often. Another idea points in a different direction. Some ice cores drilled from cave floors have shown layers that appear to be much older, possibly several thousand years, perhaps reaching back toward the end of the last ice age. If this is correct, then certain cave glaciers are quiet archives of climate, holding pollen, dust, and trapped air bubbles from a world long gone. The cracks and groans you hear would then be the voice of something ancient, slowly losing itself in a warming century. Both views have supporters. The truth may differ from cave to cave. A shallow chamber that breathes freely may hold only young ice. A deep, sealed pocket may keep its oldest layers locked at the bottom, where pressure and stillness preserve them. We do not yet have a full map of which caves hold which kind of memory. The sounds inside change with the seasons, even when the temperature does not. In autumn, when the outside air begins to chill, fresh cold pours into the entrance and the ice grows. You can hear it then, small ticks, faint pops, the soft hiss of new crystals forming. In late spring, when warm air tries to creep in along the ceiling, the ice begins to weep. Slow drops gather and fall. The cave changes its tune. The shapes inside are part of the music. Tall ice pillars rise from the floor where water has dripped for years. Sheets of clear ice coat the walls, smooth as polished glass. In some chambers, frozen waterfalls hang in mid-fall, caught between motion and stillness. When a small piece breaks free, the sound travels far. It bounces off the stone, then off the ice, then off the stone again, until it fades into the dark, Researchers who work in these places often record the sounds with sensitive microphones. They are listening for cracks too quiet for human ears, signs that the ice is shifting or thinning. From these recordings, they hope to learn how fast the underground glaciers are changing. Early results suggest that many of them are losing mass. Some chambers that held thick ice a century ago now hold only thin floors of it. Whether this is part of a natural cycle or something newer is still being studied. What remains uncertain is how much history we are losing as the ice retreats. If the oldest layers vanish before they can be sampled, their record vanishes with them. The bubbles of ancient air, the pollen from forests that no longer exist, the dust from storms that blew across a colder earth. All of it could simply drip away into the dark. For now, the ice caves keep speaking in their soft, slow voices. Each tick, each sigh, each distant drip is a small note in a song no one fully understands. Somewhere in that song is the answer to how old the ice truly is. We have not yet learned to read it. Deep inside the walls of certain caves, on the dripping films of stone, on the rims of pools that have not seen the sun, scientists sometimes find the faintest traces of life. Not animals, not plants, something smaller, slower, and far more patient. Microbes, tiny single-celled beings that may have been living in the same dark crack for a very long time. How long? No one is sure, and that uncertainty has opened one of the most quiet and beautiful questions in modern science. The numbers, when you sit with them, are strange. A surface microbe may divide every 20 minutes. In a single day, one cell can become billions. Now imagine slowing that clock down. Deep underground, where food is scarce and the air does not move, some microbes are thought to divide only once every 100 years. Some estimates stretch further still, to once every 1,000 years, or once every 10,000. The math is gentle and unsettling at the same time. A single cell sitting on a wet wall may have last copied itself when the pyramids were new. Researchers have pulled samples from deep mines, from cave waters, and from rock cores drilled into the crust. The cell counts are tiny. A teaspoon of surface soil might hold 1 billion microbes. The same teaspoon of deep cave clay might hold only a few thousand. Yet they are there. They are alive. And the energy they live on is almost impossibly small. The deep biosphere, as some researchers call it, may run on power levels 1 million times lower than the life we know above ground. There is a quiet elegance to this arithmetic. Life at the surface burns bright and fast. Life in the deep cave burns like the dimmest ember, almost not burning at all, and yet the totals are vast. Some estimates suggest that the mass of all the microbes living inside Earth's crust may equal, or even exceed, the mass of every animal and plant on the surface. The numbers are uncertain. The ratios shift with each new study, but the picture is the same. Most of the living matter on Earth may be hidden beneath our feet, breathing so slowly it looks like stillness. How old can a single microbe be? That is where the theories begin to split. One view holds that these deep cells are not truly ancient as individuals. They divide rarely, yes, but they still divide. The cell on the wall today is the great-great-grandchild of a cell that lived 1,000 years ago. By this reading, the lineage is old, but the individual is not. Another view goes further. Some researchers wonder whether certain microbes can enter a state so slow, so close to dormant, that the same single cell may persist for tens of thousands of years without dividing at all. The membranes would need constant repair. The internal machinery would need to tick over at the faintest pace. Whether that is truly possible remains an open question. The math becomes harder still when you ask how these microbes find food. On the surface, almost all life traces back to sunlight. In the deep cave, sunlight has never reached. So the microbes must live on something else. Some pull energy from sulfur in the rock. Some live on hydrogen gas seeping up from below. Some eat iron or manganese, or the slow chemistry of water meeting stone. The reactions release only the tiniest amount of energy per second. And yet, given enough time, that trickle is enough. Time in the deep cave is the resource that life has in abundance. There is a ratio worth holding in the mind. A human body uses roughly 100 watts. A deep cave microbe may use something like 1/10,000,000th of a watt. The gap is almost unimaginable. And yet both are alive. Both are doing the same fundamental work, copying information, repairing damage, holding off the slow pull toward disorder. The same rules, different speeds. What no one yet knows is where the limit lies. How deep can life go before the energy is simply too thin to sustain it? Some researchers suspect we have not found that floor. Others suspect we already have, and the deepest microbes we have sampled are near the edge. The deepest caves may hold the answer, or may simply hold more questions. Every new sample, every new drip of water gathered from a dark wall may shift the numbers again. For tonight, it is enough to picture them. Tiny lives scattered through the stone beneath the mountains, breathing so slowly that a century passes between heartbeats. The math is simple. The mystery is not. Beneath the surface of the sea, in the soft dark below the waves, lies a world of caves that almost no one ever sees. These are flooded passages, carved long ago when the sea was lower and the land stood higher than it does today. Some opened in limestone cliffs that now sit underwater. Others formed deep within islands, slowly hollowed out by fresh water meeting salt. They are among the most fragile cave systems on Earth, and also among the least understood. In places like the Yucatan in Mexico, the Bahamas, and parts of the Mediterranean, these flooded caves stretch for many miles. Some are called blue holes because seen from above they appear as deep blue circles in the pale shallows. Divers who lower themselves into these openings often pass through layers of water that look like glass walls. Fresh water floats on top. Salt water sits below. Between them lies a strange, shimmering boundary called a halocline, where the two layers meet but refuse to mix. The light bends inside it. Distant shapes seem to ripple and stretch. What makes these caves so delicate is the careful balance of all the forces that shape them. The water must stay still, or close to still. The chemistry of the layers must hold steady. The roof of stone above must not collapse. The creatures that live inside must have just enough food, just enough oxygen, just enough quiet. Change any one of these things, and the whole system begins to shift in ways we still do not fully understand. The animals down there are unlike almost anything else on the planet. Some are tiny pale shrimp that drift through the dark halicline as though suspended in clear jelly. Others are small blind fish with skin so thin you can see the faint shape of their bones. A few species seem to live nowhere else on Earth, found only inside a single cave or a single chamber of a single cave. If that one chamber were to dry out, or fill with sediment, or warm by even a few degrees, those creatures could vanish before anyone ever fully describes them. The chemistry of these underwater caves is also unusually gentle. In some passages, the lower salt layer holds almost no oxygen at all. The fresh water above carries a thin trickle of dissolved minerals from the land. Where the two meet, strange chemical reactions slowly take place. Some scientists believe that microbes living in this boundary feed on the chemistry itself, taking their energy from the meeting of two waters rather than from sunlight. Other researchers argue that the food chain still depends on tiny scraps of organic matter drifting down from above. The question of how these ecosystems truly sustain themselves remains open. The roofs of these caves tell their own quiet story. Many hold stalactites, long stone fingers that grew slowly when the cave was still dry, drop by drop, over thousands of years. The fact that they sit underwater now means the sea was once far lower. When the great ice sheets melted at the end of the last ice age, the oceans rose and the caves filled. The stalactites stopped growing. They are frozen records of a world that no longer exists, suspended in still water like the bones of a vanished room. A single change could undo all of it. A passing storm can stir sediment that takes years to settle. A small shift in sea level can flood passages that once held air pockets used by bats and crabs. A change in the freshwater flow from the land above can collapse the halicline, mixing the layers and choking out the species that depended on the boundary. Even the breath of a visiting diver can leave traces that linger for months. This delicate balance asks a quiet question. How can a system so easily disturbed have lasted so long. One idea is that these caves are far more resilient than they appear, and that small disturbances are simply absorbed and forgotten. Another idea is that we are only seeing the survivors, that countless other underwater caves once held life that did not endure, and what remains today is a thin remnant of a much richer past. Both views may hold pieces of the truth. What we do know is that these places exist in a kind of held breath. They sit just below the surface of an ordinary sea, doing what they have done for thousands of years, quietly, in the dark. How many such caves remain unfound beneath the world's coastlines? No one can yet say. The sea keeps its own counsel. The pale creatures inside drift on, in waters that still hold most of their secrets. We have walked together through many chambers tonight, and now we come to one of the quietest questions of all. How deep can a cave actually go? Not how deep we have measured, but how deep is possible. The honest answer is that no one truly knows. The deepest cave ever entered by humans is Veryovkina, in the Arabica Massif of the Caucasus Mountains. Its lowest known point sits more than 2,200 meters below the surface. That is more than 2 kilometers of stone above the explorers' heads. Below that point, the cave ends in a small sump, a pool of cold water that fills the passage completely. No one knows what lies beyond that water. The passage may continue down for hundreds of meters more, or it may pinch shut a short distance below the surface of the pool. The stone holds its secret. This brings us to a quiet debate among cave scientists. How deep can a cave reasonably go before the rock itself closes around it? One idea is that pressure sets the limit. The weight of 2 kilometers of stone presses down on every passage. At some depth, the soft limestone simply cannot hold open a void any longer. The walls would slowly squeeze inward, sealing the cave like wet clay. Under this view, 3 kilometers might be near the practical floor for most cave systems. Maybe a little more in the strongest rock. A competing view points to the work of water. Caves form where slightly acidic water dissolves the stone along cracks and bedding planes. The deeper you go, the warmer the rock becomes, and the chemistry begins to shift. Some researchers wonder whether dissolution slows so much at depth that no large passage can form past a certain point. Others suggest the opposite. Warm, mineral-rich water rising from below may carve passages we have never imagined in a process called hypogene speleogenesis. In that view, deep caves are not made from the top down by rainwater, but from the bottom up by hot fluids working through ancient faults. If hypogene caves are common, the deepest reaches of the crust may hold voids that surface-fed exploration will never touch. Neither theory is settled. The truth probably involves both. Different mountains, different stones, different climates likely set different floors. The Arabica Massif in the Caucasus may simply be a place where every condition lines up. A thick slab of soluble limestone, a high mountain pushing up, a deep base level where water can drain away. Add millions of years, and you get Veryovkina and Krubera, sitting side by side, each holding the depth record at different times. There is another open question, more troubling and more wonderful. How much of Earth's cave network remains unmapped? Estimates here are little more than guesses. Some speleologists suggest that for every kilometer of passage humans have surveyed, 10 or 20 more lie hidden in the same regions. Others believe the ratio could be far larger. Vast karst plateaus in southern China, Papua New Guinea, and the remote ranges of Central Asia have barely been touched. Sun Duong in Vietnam was only confirmed to the wider world in 2009, and it is one of the largest cave passages ever found. If something that enormous could hide until recent decades, the planet may still be holding caves of every scale, waiting in silence. The deepest mysteries may not be about size at all. They may be about life. We do not yet know how far down living things can survive in the rock itself. Microbes have been pulled from boreholes more than 2 kilometers below the surface, eating minerals and sipping at trapped water. Whether those microbes connect to true cave systems or live as isolated colonies sealed inside the stone, no one can say. Each new sample raises more questions than it answers. The boundary between cave and crack, between hollow space and saturated rock, blurs at depth. So we sit with these gentle uncertainties. Caves may bottom out at 3 kilometers, or they may reach further in places we have not yet found. Life may stop at a certain temperature, or it may continue down toward the upper mantle in forms we have not imagined. The maps we draw show only what we have walked through. Around those drawn lines, in every direction, lies the unmapped. There is something restful in that thought. The earth has not given up its secrets. Whole rooms, whole rivers, whole quiet communities of pale, patient creatures may be sitting in darkness right now, undisturbed and undescribed. They have been waiting a long time. They can wait a little longer while we rest here, wondering with them. Tonight, let us wander forward in time slowly, the way water wanders through stone. The deep caves we have spoken of will not stay the same. They are not finished places. They are still being made, even now, in the quiet dark beneath our feet. And what they will become in 1,000,000 years, or 100 million, or 1 billion, is its own gentle mystery. A cave is born when water finds a weakness. It widens that weakness, drip by patient drip, over tens of thousands of years. But the same water that opens a passage can also close it. Sediment settles, mud thickens. Calcite, that soft white mineral, slowly seals cracks the way candle wax seals a letter. Some passages that cavers walked through a century ago are already harder to enter today. Others, deeper still, may have closed long before any human ever knew they were there. In 1,000,000 years, the surface of the world will look quite different. Rivers will shift. Mountains will rise a little higher or wear a little lower. The limestone hills of Vietnam, where Sun Dung holds its hidden jungle beneath the stone, may be carved into entirely new shapes. The Caucasus Mountains, which hold Veryovkina and Krubera, will keep pushing upward as 2 continental plates press together. As the mountains rise, the caves inside them may drain, and new caves may begin forming below the old ones. Some researchers think the deepest caves of the far future have not yet started to form. In 10 million years, the very rock that holds today's deep caves may begin to weather away at the surface. The roofs of grand chambers could open to the sky, becoming canyons. Let Ichigia's mineral palaces, with their delicate gypsum chandeliers, may one day stand exposed to wind and rain, their crystals dissolving back into the soil, or they may sink deeper, buried under new layers of sediment, sealed away for a stretch of time longer than any human story. In 100 million years, the continents themselves will have shifted. The slow drift of the plates will carry today's cave systems to new latitudes. A cave that now sits beneath a temperate forest may find itself beneath a desert or beneath an ocean shelf. The blind fish and pale salamanders of the deep passages, if their descendants still live, may have evolved into creatures we would not recognize. Some scientists wonder whether cave-adapted life is one of the most stable forms on Earth, since the dark and the constant temperature change so little. Others wonder whether even these quiet refuges will be reshaped beyond imagining. In 1 billion years, the sun will burn hotter than it does now. The oceans may begin to thin. The surface of Earth may grow harsh in ways that would be hard to live through. And here is where the deep caves become curious to think about. Far below the surface, the temperature stays steady. Water still seeps through the stone. The microbes that already live in the deep rock, feeding on minerals, asking nothing of the sun, may simply continue. One idea is that the last living things on Earth, billions of years from now, will be found not in the open air, but in the warm, wet darkness of the deep crust. Another idea is that the geology itself will shift so completely that even these refuges will not survive. The question stays open, and there are passages we will never see. Some are sealed by collapse, the roof of a tunnel falling in long before humans arrived. Some are sealed by water-flooded sumps that no diver can pass. Some are sealed by gas, by chambers where carbon dioxide pools, and the air no longer holds enough oxygen for a person to breathe. These doorways may open again, slowly, as the rock settles or as the climate shifts. Or they may stay closed forever, holding their own quiet histories, never witnessed. It is a strange thing to consider, lying still in the warm dark of your room, beneath some forest, on some continent. A passage is widening tonight by the width of a single thought. A drop of water is reaching a place no light has ever touched. A chamber is being born that no human will enter for 1,000 generations, if ever. The slow work of the underworld does not wait for us. It does not need us. It simply continues, drip by patient drip, while we sleep above it. What the deep caves will become in the long unfolding of the planet is one of the gentlest mysteries. They are unfinished. They are still being written, and much of what they will be, we will never know. Step back now, as far back as you can go in your mind, and let the whole picture settle into view. A cave is a hollow place inside stone. The stone itself is older than the cave by a long stretch of time. The limestone walls of Krubera, the marble passages of Veryovkina, the bright crystal halls of Lechigia, all of them began as something else entirely. They began as life. Most of the world's great cave systems are carved from limestone. And limestone is, in a quiet way, a kind of graveyard. It is made of the shells and skeletons of tiny sea creatures that lived and died in ancient oceans hundreds of millions of years ago. Each shell drifted down through warm water. Each skeleton settled on the sea floor. Layer upon layer, they pressed together over unimaginable spans of time, hardening into rock. So when a caver descends into a deep passage, they are moving through the compressed remains of an old, sunlit sea. The walls around them were once alive. The ceiling above them was once a soft layer of mud at the bottom of a tropical lagoon. Time folded that lagoon, lifted it, buried it, raised it again into a mountain. And then water began the slow work of hollowing it out from the inside. There is something gentle about that thought. The deepest caves on Earth are negative spaces inside ancient life. They are the shape of what is no longer there, and the creatures that live in those caves now, the pale fish, the blind salamanders, the small white shrimp drifting in cold underground pools, they too are made of the same elements. The calcium in their bones is the same calcium that built the shells of those long-vanished sea animals, the same calcium that lines the inside of every drop of water seeping through the ceiling, the same calcium that grows, drop by patient drop, into a stalactite. That calcium did not begin on Earth. It was forged inside stars. Long before our planet existed, ancient suns burned through their fuel and collapsed and scattered their atoms across the dark. Those atoms drifted for ages. They gathered into clouds. They formed a young Earth. They became oceans and creatures and bones and stone. And eventually, after a very long while, a few of them became the wall of a cave, a kilometer beneath a mountain in the Caucasus. You are made of the same material. The calcium in your bones, the carbon in your breath, the iron in your blood. All of it traces back to the same source. The cave and the caver share an origin. They are old relatives meeting again in the dark. This may be why deep caves feel the way they do. People who spend time in them often describe a quiet that is more than silence, a sense of presence without company. The walls do not speak, but they remember. They hold the chemistry of vanished seas. They hold the slow record of rainfall stretching back tens of thousands of years, written in the rings of their stalagmites. They hold the bones of bears and the tracks of human ancestors and the faint chemical signatures of microbes whose lineages may stretch back further than anyone has yet measured. A cave is a kind of archive, and the archive is still being read. We do not know how deep the deepest cave goes. We do not know how far life reaches into the rock beneath our feet. We do not know how many sealed chambers wait in the limestone hills of the world, holding air that has not moved in 1,000,000 years. We may never know all of it. The earth keeps some of its records to itself, but the not knowing is part of the gift. It means the planet beneath you is still, in some real sense, unexplored. The ground you walk on is hollow in places no one has ever seen. Water is moving through stone tonight in passages that have no name. Pale creatures are drifting in pools that have no map. Crystals are growing in chambers where no light has ever fallen, and all of it, the caves, the creatures, the stone, the water, and you, lying still in the warm dark of your room, is made from the same old atoms, gathered from the same old stars, arranged for a little while into the particular shape of a world. Let that thought rest in you as you settle. The deep places of the earth are quietly keeping their secrets. The stones remember more than we will ever ask them. And the question of how deep it all goes is still gently open. And so we come to the quiet end of our long walk beneath the world. The lamps have burned low. The maps are folded. The ropes lie coiled in the corners of memory, soft and still. Outside, the night holds its breath, and somewhere far below your feet, the deep caves keep their slow, patient watch. Think for a moment of all we have wondered about together. The slow descent into Krubera, where divers found water at the bottom and could not say what lay beyond it. The colder, deeper shaft of Veryovkina, where the floor is only the floor we have reached so far. The vast hall of Sun Dune, with its jungle inside the stone and its clouds that drift along the ceiling. The mineral chambers of Lechigia, glittering with crystals no human eye saw for thousands of years. We wondered about the pale fish that swim without sight, the salamanders that live so long and so slowly that a century in their world is only a turn or two of the seasons. The microbes that may have been resting in the deep rock since long before our own kind came down from the trees. We wondered how far life can reach into the warm dark, and we let the answer stay where it belongs, for now, unfinished, open, waiting. We listened to the breath of the caves, the soft inhale and exhale of the great hollow lungs of the planet. We followed rivers that slipped into stone and came out somewhere else, or did not come out at all. We looked at the heavy pools of carbon dioxide that settle in low chambers, invisible and still. And we let the question of why some passages cannot yet be entered remain simply a question. And we sat with the harder thoughts, gently. The cavers who did not return, the bones found in old sediment, telling stories no one wrote down. The sealed doors of collapsed passages, hiding rooms that may never be seen again. We did not linger there. We only nodded to those quiet places and walked on. Now picture the earth from a soft distance. A round, blue-green world turning slowly in the dark. Half of it bathed in sunlight, half of it resting in night. Oceans glimmering under a low moon. Clouds drifting in slow white spirals. And beneath the surface, beneath the forests and the deserts and the cities and the seas, a hidden network of stone hollows of long tunnels, of crystal rooms and dripping galleries, all of it dark, all of it cool, all of it quiet. The caves do not need us. They have been there for millions of years, and they will be there for millions more. The water keeps falling, drop by drop, building its slow towers of stone. The blind fish keep their gentle circles in the still pools. The microbes keep their slow chemistry in the deep rock. The mountains keep their secrets, patient as mountains always are. You are small, and the world is large, and that is a kind of comfort. You do not have to solve the mystery of how deep the caves can go. You do not have to map the passages no one has reached. The wondering is enough. The wondering is the gift. Let your breath slow. Let your shoulders soften. Let the long day you carried fall away from you, the way a pebble falls into a deep pool and is gone, leaving only the smallest ring on the surface. The earth is turning. The caves are quiet. The stars are out, somewhere above the clouds, even if you cannot see them. The night is large enough to hold you. Tomorrow, there will be more questions, more tunnels in the dark, more pale creatures in the still water, more mountains that have not yet been measured all the way through. We will come back to the wondering when you are ready. For now, the only thing left to do is rest. The deep caves are still down there. The slow drip of water on stone. The cool, patient air. The crystals growing one atom at a time. They will keep on without us tonight. They will keep their secrets. And one day, perhaps, we will know more. Or perhaps the world will hold a little of its mystery forever, the way the best stories always do. You are safe. You are small in a kind universe. The planet is turning gently beneath you, and the quiet beneath the world is keeping its long, soft watch. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.